This is question 20 and it's a question about arithmetic sequences. And what we've got to do is we've got to find an expression for the nth term of the sequence. And an arithmetic sequence means that it's going up by the same step each time. So we can see we start off on 1, and then if we add 3, we will get the 4. And then if we add 3 again, we'll get 7. And if we add another 3, we get 10. And then we get 13. So that's how we know it's an arithmetic sequence, because it's always going up in the same step. And an arithmetic sequence, an expression for the nth term, is we have some number times n, and then we would have plus or minus some other number. And the number that goes in front of the n is the step that it goes up in each time. So we can see here it goes up in 3s. So that means I can fill that in and put a 3 there. And then for the number that we're adding or taking away, we can go back to the term before the first one. So this is the first term in the sequence. And we can imagine if we went back another step, we'd actually would have added 3 to whatever number was here. And we can see that that would have to be minus 2, because minus 2 plus 3 would give me the 1 there. So that means that I'm actually going to be subtracting 2. So that very first term, the one that's before the first term actually in the sequence as it's written, is what we have to add on to our expression. So that's our expression in terms of n for the nth term in the sequence. And you could stop there and that would give you all the marks, but I'm just going to explain how this works now. So we've got that the nth term equals this expression 3n minus 2, and what the nth term means, or what n stands for, is the position that we are in the sequence. So we can see that 1 is the first term, 4 is the second term, 7 is the third term, 10 is the fourth term, and 13 is the fifth term. And if we replace n by any of these positions, it will give us the number in the sequence. So for example, if I were to find what the fifth term was, then what I would do is I would replace n by 5, because that's now the value of n for the fifth term there. And I'd have 3 times 5 and then take away 2. And if I work that out, I've got 3 times 5 is 15 minus 2 equals 13. And we can see that is actually the value there. And this formula becomes very useful if we're asked to ever find something like the 100th term, because we wouldn't want to be just continually adding 3 on and going on forever. That would take a very long time. We could get there eventually, but it would take us a long time. So what I could do is, instead of continually adding 3s on to get whatever term I need to, I could just replace n by 100 if I wanted to find the 100th term. So I could say, well, 3 times 100 minus 2 is the 100th term. And I can see that would be 3 times 100 is 300 minus 2, and that would give me 298. So in the case, if I had been asked to find that 100th term, which does occur sometimes in GCSE questions, then I'll just put 100 into the value of n for the formula. And as I say, I've just done this extra bit just to explain how this nth term works. All you need to do to answer this question is actually do this line here. Nth term equals 3n minus 2. So I hope that's been helpful to you, and if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.